Ancient stones hold a silent conversation in numbers and angles. This video decodes the hidden mathematics embedded in ancient monuments across the globe. You will gain a new lens to see history, revealing our ancestors not as primitive builders, but as master geometers of the cosmos. We will investigate why the Great Pyramid seems to encode the number pi, and how a temple in Cambodia might be a fractal model of the universe. What forgotten truth about human ingenuity are these stones trying to tell us? This shared visual grammar connects monuments separated by oceans, and at the heart of this connection lies a profound idea known as sacred geometry. It is the study of specific shapes, proportions, and patterns that ancient cultures around the world identified as fundamental to the fabric of reality. These were not random artistic choices. The circle, the square, the spiral, and a special ratio known as the golden ratio were seen as the very alphabet of creation. The philosopher Plato famously stated that geometry is the language in which the gods wrote the universe. For these early builders, employing these forms was a way of constructing a bridge between our material world and a higher, divine order. They were literally building according to a cosmic blueprint. We see this universal consensus in symbols that appear across continents. The intricate mandalas of Hindu and Buddhist traditions are maps of the cosmos centered on a point. The interlocking circles of the flower of life pattern have been found carved into temple walls from ancient Egypt to distant China. These recurring motifs suggest a deep, pre-modern intuition about the shapes that underpin existence. So the pressing question becomes, was this shared symbolic language also a vessel for precise, practical knowledge? Did the circle and the square hold secrets about mathematics, astronomy, or even the dimensions of our planet that these builders were determined to preserve in stone? To find out, we must look at their most ambitious applications. Rising from the Giza Plateau, the Great Pyramid stands as a mathematical mountain carved from the desert. Its sheer presence is a statement in stone, but its true genius is measured not in stories, but in numbers. For over 4,000 years, it has guarded a silent puzzle in its proportions. One of the most compelling is its apparent encoding of the number pi. If you take the pyramid's original perimeter and divide it by twice its original height, the result is a value incredibly close to 3.1416. This is pi, the fundamental constant that defines the relationship between a circle's circumference and its diameter. The builders, who left no written records of pi, seem to have embedded it into the very angles of a square-based structure. This is not the only profound ratio present. The pyramid's geometry also incorporates the golden ratio, often symbolized by the Greek letter phi. This ratio, approximately 1.618, appears in the proportions of the pyramid's faces and its internal chambers, a ratio celebrated for its aesthetic harmony and frequent appearance in nature. Some researchers have proposed an even grander correlation, suggesting the pyramid's base perimeter was a deliberate scale model of the Earth's circumference, with one side representing 1 minute of latitude at the equator. The precision is staggering. The pyramid is aligned to true north with an accuracy within a fraction of a single degree, a feat that would challenge modern surveyors. Inside, the king's chamber is a masterpiece of precision stonework, its dimensions forming a perfect 2 by 1 rectangle, and its walls composed of immense granite blocks fitted with seams thinner than a credit card. How was this possible? Egyptologists point to an ancient Egyptian unit of measurement for slope. The pyramids chosen produced the now famous 52-degree angle, and from that single practical decision, all these mathematical relationships naturally emerge. So is the pyramid a deliberate repository of advanced knowledge, or a magnificent coincidence born from a simple architectural choice? Engineers marvel at the outcome, while historians debate the intent. Perhaps the truth lies in a worldview where the practical and the profound were never separate. Building to last for eternity meant building in harmony with the eternal laws they perceived in the heavens and the earth. The pyramid, therefore, is not just a tomb, but a three-dimensional theorem, a permanent argument in granite about the mathematical nature of the cosmos. If one monument can hold such layered meaning, what happens when we find the same numbers whispering from the stones of a temple on the other side of the world across the Atlantic? On the windswept Salisbury Plain, another monument speaks a numerical language written in sunrise and shadow. Stonehenge stands as a ring of silent sentinels, but for the Neolithic people who raised these stones over 4,000 years ago, it may have functioned as a colossal stone calculator. This was not a structure built for shelter or storage, but for observation, a permanent fixture on the landscape designed to capture the precise movements of the sun and moon. The genius of Stonehenge lies not in intricate carvings, but in its stark, purposeful alignments. Each year during the summer solstice, the rising sun crests the horizon to shine directly through the heart of the monument, framed perfectly by the central arch of the grate. Conversely, at the winter solstice, the setting sun aligns in the opposite direction, its last light disappearing down the same corridor. These are not chance occurrences. They required an astonishingly precise understanding of the solar cycle, achieved through generations of careful watching and recording, all without a written numeral system. The mathematical ambition of the site extends far beyond its most famous stones. Encircling the entire monument is a ring of 56 pits known as the holes, named for the 17th century antiquarian who discovered them. For a long time, their purpose was a mystery, until researchers like astronomer Hawkins proposed a revolutionary theory. He suggested that by moving markers, perhaps simple stones, from hole to hole in a specific pattern around this circle, ancient keepers could have predicted lunar eclipses. The 56-year cycle is a known period for eclipses, and this simple yet sophisticated system would have allowed a Neolithic society to anticipate these awe-inspiring celestial events, transforming a source of potential fear into a predictable spectacle of cosmic order. The geometry embedded in the landscape is equally deliberate. Four so-called station stones, placed in a rectangle around the main circle, create precise astronomical. The famous heel stone, standing alone outside the circle, serves as a critical foresight for the solstice sunrise. When you map these points, clear shapes emerge, perfect rectangles and alignments that demonstrate a sophisticated grasp of practical geometry and measurement. This reveals a society deeply engaged with mathematics, not as an abstract theory, but as a living, breathing tool for understanding time and their place within the cosmos. They were active mathematicians, using the sky as their textbook and these immense stones as their permanent notation. Stonehenge proves that complex mathematical thought does not require parchment or equations. It can be etched into the very earth, a testament to the human drive to quantify the heavens. If a culture could engineer a stone computer to track celestial time, what other forms might this embedded knowledge take? Could an entire temple complex be designed as a scale model of the universe itself, high on the Athenian Acropolis? A temple gleams white against the blue sky, a monument so familiar it has become synonymous with classical beauty itself. The Parthenon, built in the 5th century before the Common Era, is often celebrated as the birthplace of democracy and Western civilization. But to see it only as a political symbol is to miss its deeper language. This structure is, in truth, in applied mathematics, a silent lecture in stone on the principles of harmony and proportion. Its builders were not merely artisans, they were geometers in the service of an ideal. They sought to construct not just a house for the goddess Athena, but a physical manifestation of balance and reason. To achieve this, they turned to a specific, revered ratio, one we have encountered before, the golden ratio. This proportion, approximately 1.618 to 1, is woven into the Parthenon's very fabric. If you draw a rectangle around the temple's iconic, the ratio of its width to its height forms a near-perfect golden rectangle. This same harmonious shape repeats in the layout of the floor plan and the spacing of the columns. The Greeks believed this ratio was inherently pleasing to the human eye, a mathematical secret to aesthetic perfection. But the mathematical refinement goes far deeper than this one famous number. Look at the temple's core dimensions. The ratio of its width to its length is 4:9. The same 4:9 ratio governs the relationship between the width of the building and the height of its columns. Even the space between the columns relates to their diameter in this precise proportion. This was not accidental, it was a deliberate, repeated application of a harmonic system. The architects were likely influenced by the mathematical philosophies of thinkers like Pythagoras, who taught that the universe was ordered by number and that certain ratios produced consonance, whether in music or in architecture. They were building a visual symphony. Perhaps the most subtle and brilliant mathematical trick is invisible to the untrained eye. Look closely at the Parthenon's columns. They are not straight. Each column swells slightly in the middle, a gentle curve known as Entasis. Why would the builders, who sought perfect straight lines, intentionally introduce a curve? The answer is a profound understanding of human perception. If they had built the columns perfectly straight, an optical illusion would make them appear to bend inward under the weight of the massive stone lintels above. By adding this calculated outward curve, they corrected for the eye's deception. The result is a temple that looks perfectly rectilinear, strong, and stable. It is a mathematical solution to a sensory problem, proving that their genius was both philosophical and profoundly practical. Architectural historians note that every measurement, every slight adjustment, was in pursuit of an ideal form that felt both intellectually sound and spiritually resonant. This raises a profound question that the Parthenon poses across the: is beauty itself mathematically defined? Did the ancient Greeks, through rigorous study and artistic intuition, come closer than any civilization before or since to discovering its foundational formula? The Parthenon stands as the ultimate argument that aesthetics and arithmetic are not separate realms, but two expressions of the same underlying truth. It is a testament to the belief that to build beautifully, one must first calculate wisely. The same principles of cosmic harmony echo in the sun-baked ruins of a very different world. Far from the Greek Isles in the high valley of Mexico lies a city so meticulously planned it feels less like a collection of buildings and more like a vast instrument laid upon the earth. The city of the gods was a metropolis of staggering scale, home to over 100,000 people at its zenith. Its two colossal pyramids, dedicated to the sun and the moon, anchor a landscape dominated by a central artery known as the Avenue of the Dead. To walk this avenue today is to traverse a master blueprint, a grand mathematical equation solved not on parchment, but in stone and space. The genius of builders was one of measurement and alignment, a systematic approach that governed every aspect of the city's design. Archaeologists have discovered that the entire urban plan was based on a single, standard unit of measurement, approximately 83 centimeters in length. This unit is not a rough estimate. It is a precise constant found repeated in the dimensions of plazas, the widths of streets, and the intervals between structures. The city itself was a physical manifestation of a standardized system, a testament to a highly organized society with a shared mathematical vision. This precise planning extended far beyond the ground, reaching directly into the heavens. The central Avenue of the Dead is not aligned to true north, as one might expect. Instead, it points 15.5 degrees east of north. Why such a specific, deliberate offset? Researchers believe this alignment was celestial. At the time of the city's founding, this orientation would have pointed directly toward the setting of the Pleiades star cluster, a group of stars deeply significant in cosmology, often associated with agriculture and the calendar. Furthermore, the west-facing pyramid of the sun is aligned so that the sun sets directly behind it on specific days of the year, likely marking key dates in the agricultural cycle. This was urban planning as a form of sacred astronomy. The entire city functioned as a colossal calendar and observatory, its streets and monuments acting as to capture the rhythm of the cosmos. The vast sunken plaza at the southern end of the avenue is another geometric puzzle. Its precise orientation and the angles of its surrounding platforms have led some researchers to propose it functioned as a kind of calendrical computer, its architecture encoding information about the solar year and longer cycles of time. Experts in studies suggest these alignments were far more than symbolic, they were practical and spiritual tools. By marking the solstices, the equinoxes, and the cycles of important star groups, the city's rulers could predict the coming of rains, schedule planting and harvests, and time major religious ceremonies that reinforced their connection to the divine order. Demonstrates that mathematics for its builders was the essential language of power, prophecy, and survival. It was the framework that connected the mundane needs of a thriving city to the majestic movements of the stars, proving that a truly great civilization could measure its gods and its grain with the same unwavering standard. This drive to encode cosmic order into architecture seems to be a universal human impulse. But what happens when that impulse is expressed not in massive pyramids, but in intricate, repeating patterns that spiral inward toward infinity deep in the Cambodian jungle? A stone universe rises from the earth. Angkor Wat is more than a temple. It is a three-dimensional map of an entire cosmology, a breathtaking attempt to build heaven on the ground. At its heart lies the symbolic form of Mount, the sacred mountain believed to be the axis of all creation in Hindu and Buddhist tradition. The 5 iconic towers you see are not just spires, they are the peaks of this cosmic mountain, with the central, tallest tower representing its summit. The vast moat surrounding the complex is not merely for defense, it symbolizes the primordial ocean that encircles the world. To walk from the outer walls toward the central sanctuary is to journey symbolically from the edge of the material world toward the spiritual center of the universe. This architectural storytelling is achieved through a sophisticated and deliberate use of mathematics. The entire layout is a masterpiece of fractal geometry. Look closely, and you will see that the form of the grand central tower is replicated in miniature by the smaller towers surrounding it. These, in turn, are echoed in the design of the galleries and gateways. It is a pattern of self-similarity, where the same shape repeats at different scales, creating a sense of infinite regress, a microcosm reflecting the macrocosm. The builders were not just stacking stones, they were encoding a philosophical principle that the structure of the whole is contained within every one of its parts. This mathematical precision extends to the temple's extraordinary bas-reliefs. The West Gallery holds the famous depiction of the churning of the ocean of milk, a pivotal creation myth. Scholars studying the scene have noted that the number of divine and demonic figures involved, along with the specific iconography, may correspond to units of cosmic time, representing vast cycles of creation and dissolution known as yugas. The temple itself appears to be a giant timepiece. Researchers have measured its dimensions and found startling correlations. The distances between certain key points within the complex seem to mirror astronomical periods, such as the durations of lunar months or solar years. This suggests the temple was designed not only as a spiritual map, but also as a permanent calendar, its very stones marking the passage of celestial time. Perhaps the most telling clue is its orientation. Unlike every other major temple at Angkor, which face east toward the rising sun, Angkor Wat faces west. This unique alignment has sparked much debate. Some see it as a funerary symbol for the king who built it. Others propose a more celestial reason. The Western orientation creates a dramatic alignment during the equinoxes, where the sun rises directly over the central tower when viewed from a specific point. This would transform the temple into a precise solar marker, its shadow and light acting as hands on a colossal sundial. Angkor Wat demonstrates, perhaps more clearly than any other monument, that for its creators, mathematics was the essential language for making the invisible visible. It was the tool they used to translate myth into masonry, to map eternity onto a human scale, and to build a bridge between the fleeting moment and the timeless cycle. If temples can be clocks and mountains can be built from stone, what does this recurring pattern tell us about the human mind itself? Why do we find this same drive to encode the cosmos in architecture, appearing independently across the globe? These global echoes of measurement and alignment lead us to a truly profound mystery. What if the ancient builders were not just using math, but were all speaking the same mathematical language, using the same ruler? This is the controversial claim at the heart of a concept known as the megalithic yard. For decades, a Scottish engineer named Alexander surveyed hundreds of stone circles and alignments across Britain and France. He took thousands of precise measurements, and a startling pattern emerged. He proposed that the builders of these sites, from Stonehenge to remote Scottish moors, all used a standard unit of length. He called it the megalithic yard, equivalent to about 2.72 feet, or roughly 83 centimeters. According to, these monuments were not rough circles. He identified sophisticated geometric shapes, precise ellipses, flattened circles, and even complex egg-shaped rings, all constructed using whole multiples of this single unit. His work suggested a pan-European tradition of advanced surveying and a shared system of measurement, implying a level of communication and standardization among prehistoric cultures that historians had never considered. The implications are staggering. It hints at a lost network of knowledge, where builders across a continent agreed on the length of a fundamental step. But this idea is far from settled. Skeptics offer powerful counter-arguments. They suggest that the patterns saw could arise from simple, practical construction methods. If you fix a rope to a central stake and walk it out to mark a circle, the natural human stride could create a consistent unit without any formal decree. The apparent geometric complexity, they argue, might be a modern interpretation projected onto structures that were, for their builders, primarily ritual spaces. The debate forces us to confront a fundamental question. Are we seeing the shadow of a forgotten, universal science, or are we witnessing the independent discovery, again and again, of the most practical human-scale measurements? The megalithic yard is not alone. We see similar standardized units in other great civilizations. The ancient Egyptians built the pyramids using the royal cubit, a measure of about 20.6 inches, which was itself subdivided into smaller, consistent units like palms and digits. Temples and tombs were laid out in exact multiples of this cubit, a practice so rigorous it functioned as a national building code. In Mesopotamia, the Sumerians used a unit called the foot, approximately 33 centimeters, which they derived from the weight of water, and used to standardize everything from land plots to city walls. So, does this point to a shared, ancient source of knowledge, a single revelation of measurement that spread across the world? Or does it reveal something even more fundamental about human ingenuity? Perhaps, when faced with the need to build something monumental and lasting, the human mind, the human body, and the materials at hand naturally converge on similar solutions. The length of a forearm becomes a cubit. A comfortable double step becomes a yard. The need for right angles and stable foundations leads independently to the same geometric principles. This mystery of the megalithic yard ultimately challenges our modern assumption of prehistoric isolation. It asks us to consider whether the ancient world was far more interconnected through trade, migration, and the exchange of ideas than we have credited, or if the underlying mathematics of our reality are simply so consistent that different cultures, in different times, kept stumbling upon the same eternal truths and embedding them in stone. If a standard unit of measure whispers from the stones of Europe, what other forms of encoded knowledge might be waiting, not in grand monuments, but in the very artifacts of daily life? The stones we have walked among were not just monuments to the earth, but permanent eyes fixed upon the heavens. Across continents, ancient builders turned their greatest works into giant, immovable instruments, designed to capture the precise dance of the sun, moon, and stars. This was astronomy written in stone, a calendar for the ages. To understand their ambition, we need to define a few celestial moments they revered. A solstice marks the sun's farthest journey north or south in the sky, giving us the longest day or the longest night of the year. An equinox is the balance point, when day and night are of equal length. More subtle is the lunar standstill, the point where the moon's own wandering path across the sky reaches its extreme limit, an event that only repeats every 18.6 years. These were the cosmic signposts ancient cultures sought to mark with unerring precision. The simplest and most common alignments are solar. In Ireland, the great Neolithic tomb is a masterful example. A long, narrow passage leads to a central chamber, and above the entrance sits a unique feature called the roof box. For just a few minutes at dawn on the winter solstice, and for several days around it, a single beam of sunlight pierces this opening. It travels down the dark passageway to dramatically illuminate the inner chamber, a ray of golden light in the deepest dark of the year. This was clearly no accident. It was a meticulously engineered spectacle, a promise of the sun's return, and perhaps a symbolic rebirth for those honored within. But some monuments reveal an even more complex understanding of the sky, tracking the more elusive moon. On the Mediterranean island of Malta, the temple complex, built over 5,000 years ago, is a labyrinth of stone. Have found that during the equinoxes, the first light of sunrise shines directly through the main doorway to strike a specific stone slab deep inside. Yet the temple's southernmost chamber appears to be aligned to the extreme southern rising points of the sun and moon during solstices and standstills. This suggests the builders were not just marking single events, but mapping the entire rhythmic pattern of the cosmos. Why go to such extraordinary lengths? The reasons were profoundly practical and deeply spiritual. For agricultural societies, knowing the exact timing of the solstices and equinoxes was essential for planting and harvest. For rulers and priests, the ability to predict these celestial events was a source of immense power, legitimizing their authority as intermediaries with the divine forces that governed time itself. The ceremonies held at these moments would have reinforced the social and cosmic order. Yet proving intentionality in these ancient alignments is a significant challenge, as noted by astronomers like Clive. The sky is full of potential alignments, and with a monument having many stones, the odds of one lining up with a major solar or lunar event by pure chance are not negligible. The key is to look for repetition, for multiple lines of sight within a single site that all point to significant celestial events. This moves the evidence from coincidence to design. One of the most elegant and undeniable examples of this intentional design comes from the American Southwest. At Canyon in New Mexico, high on a canyon wall called Butte, 3 large stone slabs lean against the rock face. Behind them, ancient artists carved a spiral petroglyph into the cliff. For most of the year, the spot is unremarkable, but at noon on the summer solstice, a dagger of sunlight slices perfectly between the stones to bisect the center of the spiral with a brilliant blade of light. At the winter solstice, 2 daggers of light appear, perfectly framing the same spiral. This phenomenon, known as the sun dagger, is a breathtakingly precise and delicate instrument, a celestial clock that required an intimate, generations-long knowledge of the sun's changing path. It reveals a deep, universal human desire not just to observe time, but to quantify it, to ritualize its passage, and to embed the living mathematics of celestial motion into the static certainty of architecture. The stones became a meeting place for the eternal and the ephemeral. If our ancestors could build such perfect clocks to mark the year, what other cycles of time, far longer than a single human life, might they have sought to measure and memorialize? But the mathematics of the ancient world goes far deeper than alignments and measurements. It reaches into the very shapes that define space itself. One of the most intriguing puzzles is the widespread, almost instinctive use of a specific geometric tool, the right-angled triangle with sides that are pleasing whole numbers. Today we call these Pythagorean triples, the most famous being the 3-4-5 triangle, where 3 squared plus 4 squared equals 5 squared. This is the bedrock of the theorem attributed to the Greek philosopher Pythagoras, who lived around 2,500 years ago. Yet the stones tell a different, much older story. These precise triangles appear in the layouts of monuments built before Pythagoras was born. This is not a matter of vague resemblance. Within the Great Pyramid, the niche in the so-called King's Chamber has dimensions that, when analyzed, correspond almost exactly to a 12-35-37 triangle, another perfect Pythagorean triple. At Stonehenge, researchers have proposed that the positions of key stones and holes form right-angled triangles with sides based on whole numbers, suggesting the builders used these reliable shapes to lay out their colossal circle with perfect accuracy. How could cultures separated by vast distances and time have all grasped this same geometric truth? The answer may lie not in advanced classrooms, but in the dusty fields of ancient surveyors. Historians of mathematics point to a simple, brilliant technique known as rope stretching. Imagine a team of ancient builders with a long, knotted rope. By taking 12 equally spaced knots, they could form a triangle. If they stretched the rope so one side had 3 intervals, the adjacent side had 4 intervals, and the remaining side automatically measured 5 intervals, they would have created a perfect right angle at the corner where the 3 and 4 lengths met. This method, attributed to the Egyptian or rope stretchers, required no abstract theory. It was hands-on, empirical engineering. The consistent result, a perfectly square corner, was what mattered for laying out temple foundations or squaring the base of a pyramid. The discovery of the mathematical rule behind it could have come later, as a beautiful explanation for a reliable practice. This presents us with a fascinating enigma that blurs the line we draw between skill and science. Does the presence of these Pythagorean triples in ancient monuments prove they possessed advanced theoretical mathematics? Or does it simply demonstrate an extraordinarily sophisticated tradition of practical engineering, where the rules were discovered through repeated action and encoded in craft traditions passed down through generations? Experts note that the independent discovery of geometric principles is a common theme in human history. When multiple cultures face the same fundamental problem, like building large, stable, rectangular structures, they often converge on the same elegant solution. The 3-4-5 triangle is arguably the simplest and most reliable way to create a true right angle without modern instruments. Its appearance across the ancient world may be less a sign of shared secret knowledge and more a testament to the universal human capacity for pattern recognition and problem solving. It reveals a profound truth about our ancestors. They were brilliant applied mathematicians long before mathematics was formalized as a separate discipline. Their theorems were not written on papyrus, but proven in the perpetual right angles of their greatest creations, a silent, enduring argument that the most eternal truths are often those we discover with our hands. But this drive to find perfect shapes in ancient stones leads us to one of history's most seductive mathematical ideas. It is a number whispered in the spirals of seashells, the branching of trees, and supposedly etched into our greatest monuments. The golden ratio, approximately 1.618 to 1, is often described as the most beautiful proportion in the universe. Mathematically, it is the unique ratio where a line divided into 2 parts makes the whole length to the longer part equal to the longer part to the shorter part. Its connection to nature is often illustrated through the sequence, a series of numbers where each is the sum of the 2 before it, starting with 0 and 1. The sequence runs 0, 1, 1, 2, 3, 5, 8, 13, and so on. As the numbers grow, the ratio between successive numbers gets closer and closer to the golden ratio. This elegant pattern appears in the arrangement of sunflower seeds and the unfurling of a fern, so it is profoundly compelling to think our ancestors recognized and revered this same pattern in their sacred art. The claims are legendary. We have already noted its possible presence in the Parthenons. At Giza, some researchers propose that the golden ratio defines the Great Pyramid's slope, with the pyramid's apothem, the line from its apex down the center of a face, relating to half its base in this divine proportion. Some even suggest the entire layout of the three main pyramids at Giza forms a triangle whose dimensions are based on this ratio. The allure is powerful. It suggests a hidden code of beauty, a universal standard consciously applied from Athens to Egypt. Yet a chorus of modern scholars urges caution, inviting us to look more critically at the measuring tape. Mathematicians and others have meticulously examined many of these famous claims. Their counter-argument is sobering. They suggest that with a flexible enough approach to where you start and stop your measurements on a complex, often ruined structure, you can find almost any number you are looking for, a process sometimes called number juggling. The Parthenon, for instance, has been damaged and rebuilt over centuries. Which set of current dimensions do you use to prove the original intent? The Great Pyramid has lost its smooth outer casing stones, making its original apex height a subject of estimation, not certainty. When you can choose from multiple possible points on a large monument, the probability of finding a ratio close to 1.618 by chance increases significantly. This leads us to a crucial psychological concept, apophenia. It is the human tendency to perceive meaningful connections or patterns within random or meaningless data. Our brains are incredible pattern recognition machines, sometimes too good, seeing faces in clouds or hearing hidden messages in recorded music played backward. The golden ratio is so aesthetically pleasing and mathematically elegant that we are primed to discover it everywhere, especially in creations we already consider masterpieces. So where does the truth lie? It likely exists in a nuanced middle ground. There is a significant difference between an architect intentionally using a precise mathematical constant and a builder working from a tradition of proportions that simply feel harmonious. Many ancient cultures, from the Greeks with their pursuit of ideal forms to the stonemasons of Egypt, developed sophisticated canons of proportion for their art and architecture. These systems, like the Egyptian grid used for statues, created balanced, pleasing works. It is entirely possible that through trial, error, and refined aesthetic intuition, these canons converged on proportions that are close to, but not rigorously, the golden ratio. They were likely seeking what felt right, not calculating to the fourth decimal place. This distinction is vital for anyone exploring historical mysteries. To critically assess such claims, we must ask for the archaeological context. Is there any contemporary written or artistic evidence from the builders themselves that mentions this specific ratio? Do the measuring points used in the analysis correspond to clear, intentional architectural features, or are they somewhat arbitrary? Does the same ratio appear consistently across multiple elements of the structure when measured objectively? This balanced view does not diminish the wonder of these monuments. Instead, it reframes the conversation. Whether by deliberate calculation or by the slow refinement of human taste, these structures embody a profound harmony that continues to resonate. The golden ratio's enduring allure speaks less to an ancient secret and more to a timeless human quest to find and create order in a vast and mysterious cosmos. And if our search for perfect ratios can sometimes lead us astray, it begs a deeper question. What other forms of ancient knowledge, far more concrete and demonstrable, have we overlooked because they lack this same romantic appeal? The quest for universal geometry now takes us to a continent whose ancient intellect is often overshadowed by its later history. In the rolling hills of what is now Zimbabwe, a city of stone rises, a testament to a forgotten kingdom that mastered the mathematics of power. Great Zimbabwe, built between the 11th and 15th centuries, was the heart of a vast trading empire that connected the African interior to the Swahili coast and beyond. Its ruins are not pyramids or temples in a familiar sense, but something equally profound, a complex geometric diagram of a functioning society. The most striking feature is the Great Enclosure, a massive oval wall standing over 30 feet high in places, constructed entirely without mortar from precisely cut granite blocks. To walk inside is to stand within a perfect ellipse, a shape far more difficult to construct accurately than a simple circle. This was no haphazard fortification. The consistency of the wall's curvature and its uniform thickness, maintained over its entire 800-foot perimeter, reveals a master plan. Archaeologists who have studied the site note that this required a standardized unit of measurement and advanced dry stone walling techniques passed down through generations of specialists. Each stone was carefully selected and shaped to fit with its neighbors, creating walls so stable they have endured for nearly 1,000 years. The geometry here served a clear social function. Within the great enclosure, a narrow, parallel-walled passage leads to the most iconic structure of all, a solid conical tower that mirrors the shape of a nearby granary. This layout is widely interpreted as a spatial expression of hierarchy. The enclosed, private spaces were likely reserved for the royalty and rituals that legitimized their rule, while the surrounding valley housed the citizens and artisans. The very design physically separated sacred authority from public life, using walls and pathways to codify social order in stone. But the mathematics of Great Zimbabwe extended beyond social control into the realm of global economics. This was a wealthy state, trading gold, ivory, and copper for glass beads and Chinese porcelain from across the Indian Ocean. Some researchers propose that the site's architects incorporated astronomical alignments to time these crucial commercial cycles. Certain wall alignments and openings may have been designed to mark the rising of specific stars or the solstices, providing a reliable, celestial calendar to coordinate the preparation of goods for the annual trading caravans to the coast. This transforms the ruins from a mere palace into a kind of administrative clock, where celestial mathematics directly governed economic prosperity. The achievement of Great Zimbabwe dismantles any narrow view of ancient mathematics. Here, geometry was not solely for worshipping the cosmos, but for building a state. It was the practical tool for organizing labor, demonstrating royal power through monumental walls, facilitating long-distance trade, and structuring a complex society. It proves that the drive to quantify and order the world is a universal human trait, one that in southern Africa found its ultimate expression in the elegant, enduring curves of dry stone. High in the cloud forests of the Andes, a city of stone defies gravity itself, is a breathtaking testament to how the Inca civilization did not merely build on a mountain, but performed a mathematical conversation with it. Every terrace, every wall, every step in this royal estate is a calculated response to the extreme and unforgiving topography. The Inca were master geometers of the living earth, and their greatest achievement reveals a profound philosophy that architecture should not conquer nature, but harmonize with its existing mathematical language. To achieve this empire-wide harmony, they relied on a precise and universal tool, a unit of measurement known as This was the standardized Inca yardstick, approximately the length of a man's outstretched arms, and it was used to plan everything from a humble storehouse to a monumental temple complex-like. By building everything in multiples of the Inca could dispatch teams of specialized laborers, called to any corner of their vast empire with a shared blueprint. A builder from Quito would understand the dimensions of a project identically, allowing for the rapid, cohesive construction of an infrastructure network spanning thousands of miles. This mathematical standardization was the invisible framework that held the empire together. But their genius is most visible in the signature shapes of their architecture. Look at any doorway or window you will not find a single perfect rectangle. Instead, every opening is a trapezoid, wider at the base and narrowing toward the top. This was not an aesthetic whim, it was a brilliant seismic solution. The Andes are one of the most tectonically active regions on Earth, subject to frequent and powerful earthquakes. A rectangular frame under stress tends to collapse, its right angles becoming points of failure. A trapezoidal shape, however, is inherently more stable. When seismic waves shake the ground, The slanted sides of the trapezoid allow the structure to flex and dissipate energy without catastrophic collapse. It is a perfect marriage of form and function, where a simple geometric understanding literally kept the city standing for centuries. This practical mathematics extended to their reverence for the sky. At the highest point of the sacred plaza sits the stone, a gracefully carved granite pillar whose name translates to the hitching post of the sun. Researchers believe this was a sophisticated astronomical instrument. Its carefully angled planes and precisely positioned protrusions are aligned to catch the sun's shadow at specific moments. During the equinoxes, the sun is said to cast no shadow at all from the central pillar, while on the solstices, the shadow falls in distinct, marked positions. It functioned as a celestial calendar, allowing Inca priests to pinpoint the turning points of the solar year with remarkable accuracy, essential for scheduling the agricultural and religious cycles that governed their world. Yet perhaps the most understated marvel of mathematics flows silently beneath your feet. The entire city is crisscrossed by an intricate network of stone channels, a masterpiece of hydraulic engineering. These channels were designed with a precise, constant gradient, a subtle downhill slope that ensured a steady, controllable flow of fresh spring water to fountains, baths, and agricultural terraces. Calculating this gradient over such rugged, uneven terrain required an advanced understanding of angles and elevation. They engineered a system that prevented erosion, minimized turbulence, and provided a reliable water supply year-round, turning a precipitous mountainside into a self-sustaining sanctuary. Therefore, stands as the ultimate expression of Inca mathematics, a discipline that was never abstract. It was the essential tool for unifying an empire, for defying earthquakes, for capturing the sun, and for coaxing water from stone. They did not see a mountain and dream of flattening it. They saw a mountain and calculated how to become a part of its own enduring geometry. Yet a perfect design is only the beginning of the story. The real mathematical miracle happened in the doing, in the monumental challenge of turning a blueprint into a mountain of stone. We must shift our gaze from the elegant proportions on parchment to the dust-choked reality of the quarry, the riverbank, and the construction site. How do you calculate the logistics of moving a 200-ton block of granite across 20 miles of desert, or lift a 50-ton lintel 30 feet into the air without a single crane? These were not feats of brute strength alone, but of applied mathematics solved in real time by thousands of anonymous engineers. Every step presented a new equation. Quarrying a stone required knowing the precise angles to drive wooden wedges into a bedrock seam, then soaking them with water so they would expand with enough controlled force to crack the stone along a clean line. Transporting it meant calculating the necessary workforce. For a sled carrying a massive block, the coefficient of friction between wood and wet sand had to be understood, even if not formally named. Teams would have known that a certain number of men pulling on ropes at a specific angle could generate enough force to overcome that friction, and that pouring water in front of the sled reduced the resistance in a predictable way. These were living, breathing calculations of force and motion. The great lifting operations demanded even more sophisticated geometry. The use of levers, a simple machine, relies entirely on the mathematical principle of mechanical advantage. By placing a fulcrum at a precise point along a timber, a small force applied over a long distance on one end can generate a large force over a short distance on the other, allowing a small team to pivot a colossal stone a few critical inches. Building an earth or ramp to raise stones to the top of a growing pyramid was itself a colossal exercise in volume calculation. Engineers today estimate that a single straight ramp to the top of the Great Pyramid would have required a volume of material nearly as great as the pyramid itself. This leads to the enduring debate among archaeologists and engineers. Was it a single long ramp, a spiraling ramp wrapped around the structure, or a series of smaller, internal ramps? Each theory is fundamentally a mathematical model, debating the optimal slope for pulling sleds, the stability of different ramp angles, and the most efficient use of material and labor. Modern engineers who have attempted small-scale reconstructions often express a profound respect for these ancient project managers. They note that the solutions were likely elegant and context-specific, using local materials like sand, gypsum plaster, and timber in clever combinations that turned simple physics into a controlled, repeatable process. But the mathematics extended far beyond the construction site. Organizing a workforce of thousands, perhaps tens of thousands, for decades was a staggering feat of logistical calculation. This was humanity's first large-scale project management. Officials had to solve problems of resource allocation on a grand scale. How much food, water, and beer was needed daily to sustain the workers and their families? How many scribes were required to track the distribution of tools and supplies? How were shifts organized to keep the work progressing continuously? The remains of worker settlements near the Giza Plateau reveal not a scene of hardship, but of organized, state-supported community with bakeries, hospitals, and housing, all requiring careful planning and inventory mathematics. This humanizes the achievement in a vital way. The true wonder is not just the mind of a single visionary architect, but the collective intelligence of countless anonymous supervisors, foremen, and laborers. Each was a practical mathematician, solving daily problems of angles, weights, and volumes. They were the ones who translated sacred geometry into a schedule, a ration, and the slow, sure ascent of a stone into the sky. Theirs was a mathematics of mud, sweat, and relentless, incremental progress, proving that the greatest equations ever solved were not written on papyrus, but enacted by the movement of countless hands across generations. Isolated in the vast Pacific, a silent council of stone giants holds the secrets of a vanished world. The of Easter Island are far more than the brooding faces we recognize. They are the pinnacle of a complex system of ancestor worship, engineering, and a hidden mathematical order that governed life on the most remote inhabited island on Earth. To understand their true purpose, we must look past the statues themselves to the foundations they stand upon, the meticulously constructed platforms known as ahu. These are not simple piles of rock. Many are long, gracefully curved walls built with interlocking, finely worked stones, a technique reminiscent of the master stonemasons of the Andes or the builders of Great Zimbabwe. The precision is deliberate. The curvature of an ahu is often a perfect arc of a massive circle, requiring the builders to calculate a consistent radius and maintain it along the entire length of the wall. This is geometry on a grand, ceremonial scale, transforming a functional retaining wall into a segment of a cosmic circle laid upon the shore. The alignments of these platforms add another layer of intention. Several major ahu, like the famous site of, are oriented so that their long walls face the rising sun during the solstices. At the equinox, the sun sets directly behind specific statues on certain platforms, framing the giant heads in a halo of light. This suggests the entire coastal landscape was engineered as a solar observatory, where the ancestors, embodied in the, participated directly in the annual cycle of the sun. The mathematics extended to the statues they supported. While each has a unique character, their proportions are remarkably consistent, following a strict cultural canon. Studies of the statues reveal they were carved using a standardized system of measurement. The ratio of the head to the body, the placement of the eyes and ears, even the angle of the sloping forehead, all adhered to a shared template. This implies a guild of master carvers who worked from a common, unwritten blueprint, using their own body parts or a set of standard measuring cords to replicate the sacred form generation after generation. This was mathematics in service of cultural continuity, ensuring that every new ancestor statue was a correct and proper vessel for the spirit it was meant to host. Yet the island's story holds a darker, more cautionary turn. As the society grew and the statue cult reached its peak, the competition between clans to erect larger, more impressive, became an all-consuming endeavor. The environmental cost was catastrophic. The once forested island was stripped of trees, likely needed for rollers and levers to transport the massive statues. Soil erosion followed, crippling agriculture. In this period of crisis, a new and complex ritual system emerged, centered not on the inland quarries, but on the sacred clifftop village of. Here, the focus shifted from ancestral giants to a perilous competition known as the Birdman cult. The village's stone houses are themselves architectural puzzles, built into the slope with ingenious dry stone masonry. More intriguing are the hundreds of petroglyphs carved into the rocks, depicting the Birdman deity and the sooty tern. Some researchers, like William, have proposed that the layout of and from its houses were designed to track the annual arrival of the first tern egg from the offshore islet of, the central event that decided the island's ritual leader for the year. This suggests a shift from a solar calendar, marked by the static, to a lunar or seasonal calendar tied to animal migration, a desperate adaptation in a changing world. The collapse of the civilization is a profound lesson etched in the landscape. It demonstrates with stark clarity that even the most sophisticated mathematical planning for ritual and social cohesion is not enough. When that ingenuity is not also applied to sustainable environmental management, the entire system can fail. They stand today not only as monuments to a people's incredible skill and spiritual devotion, but also as silent sentinels of a limit reached. They remind us that the universal impulse to measure, align, and build is a powerful force, one that must be balanced with an equally deep understanding of the fragile world we build upon. This leads us to a final, unifying question. If this mathematical impulse is truly universal, appearing from the Pacific to the Mediterranean, could there be a single, underlying reason why? What does this shared drive tell us about the fundamental nature of human consciousness and its relationship to the cosmos? The silent language of stone speaks not only in shapes, but in the very numbers used to count them. Beyond the geometry of circles and triangles lies a deeper layer of meaning, where numbers themselves were seen as sacred, carrying the weight of cosmic order and divine truth. This is the world of ancient numerology, where a number was far more than a quantity. It was a symbol, a key to understanding the structure of reality. Across cultures, specific numbers became powerful vessels for cosmological, theological, and philosophical ideas. The number 3, for instance, is almost universally seen as a symbol of harmony and completeness. We see it in the Christian trinity of Father, Son, and Holy Spirit, in the triple goddess of many pagan traditions, and in the 3 realms of heaven, earth, and the underworld common to countless mythologies. 4 grounded this celestial harmony to the earth, representing the cardinal directions, the seasons, and the elemental forces of nature, a concept central to traditions from Native American cosmology to ancient Chinese philosophy. 7 held a special place in the ancient sky, corresponding to the 7 classical planets visible to the naked eye: the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. This celestial committee governed the days of the week and was believed to influence all earthly affairs. 12 expanded this order further, mapping the path of the sun through the 12 signs of the zodiac and creating a framework for tracking the year. Even a number like 40, found in stories from the biblical flood to the desert wanderings of the Israelites, often symbolized a period of trial, purification, or profound transition. This symbolic numerology did not remain an abstract idea. It was physically forged into the monuments themselves. A temple might be supported by 12 pillars, not just for structural necessity, but to represent the 12 months or the 12 Olympian gods. A Mesopotamian ziggurat was often built with 7 tiers, a literal staircase ascending through the 7 planetary heavens. The 3 chambers of a Neolithic tomb could mirror the 3 worlds of the cosmos. As scholars of religious studies note, sacred architecture has always been a primary medium for encoding these numerical truths into the physical landscape. The building becomes a textbook, its very dimensions and repetitions teaching theological and astronomical principles to the initiated. This creates a fascinating puzzle for modern observers. When we archaeologists measure a monument and find a recurring number, like the 56 holes at Stonehenge or the specific count of statues along a processional way, we must ask a nuanced question. Are we looking at a practical mathematical constant, a deeply symbolic code, or a brilliant fusion of both? The 56 holes likely served a predictive function for eclipses, a mathematical tool. But the number 56 itself may also have held a symbolic meaning, perhaps relating to cycles of time or generations, that is now lost to us. This symbolic layer adds profound depth beyond mere measurement. It suggests that for the builders, the act of construction was an act of philosophy. Placing 12 columns was not just an engineering decision, it was an invocation of celestial order, a way to make the temple a microcosm of a harmonious universe. The stones were not silent, they were chanting in numbers, repeating a sacred numerical mantra that connected the human realm to the divine. So the next time you stand before an ancient structure, look beyond its size and shape. Count the number of steps, the repetitions in a frieze, the divisions of a space. You might just be listening to the forgotten vocabulary of a sacred code, where mathematics and meaning were woven together into a single, enduring testament to a world seen through numbered eyes. But what if this cosmic mathematics could be held in your hands? In the silent depths of the Aegean Sea, near the island of, a corroded lump of bronze lay hidden for over 2,000 years. When sponge divers recovered it from a Roman shipwreck in the year 1901, it was initially dismissed as a piece of nautical debris. Decades later, careful cleaning and modern imaging techniques revealed the truth: this was not debris at all. It was the shattered remains of the most sophisticated mechanical device the ancient world ever produced, a breathtaking artifact now known as the mechanism. It is, without question, the world's oldest known analog computer. Its purpose was not to crunch numbers for accounting, but to model the heavens themselves. This intricate bronze machine, no larger than a shoebox, was designed to predict the positions of the sun, the moon, and the 5 known planets. It could forecast eclipses, and it even tracked the cycles of ancient athletic games like the Olympics. It was a portable cosmos, a universe of mathematical relationships made tangible through a labyrinth of precisely cut bronze gears. The genius of the mechanism lies in its internal architecture. Researchers using advanced 3-dimensional X-ray scanning have painstakingly reconstructed its complex gear trains. They found systems of interlocking wheels that did far more than simply turn at a constant speed. One of its most astonishing achievements was modeling the lunar anomaly, the moon's irregular speed as it orbits the Earth. Ancient astronomers knew the moon does not move at a constant pace. It speeds up and slows down in a predictable cycle. The mechanism's designers solved this problem with a brilliant piece of mechanical engineering, a pin and slot device on a special gear that introduced a subtle, varying motion, perfectly mimicking the moon's observed wobble in the sky. This was mathematics in motion, a differential gear system thought to have been invented over a millennium later. The device also tracked grand celestial cycles with remarkable precision. It encoded the metonic cycle, a period of 19 years after which the phases of the moon repeat on the same calendar dates. It also incorporated the Saros cycle, a period of approximately 18 years and 11 days used to predict eclipses. To achieve this, the gear ratios had to be exquisitely accurate. Some of the gears have tooth counts that are prime numbers, like 127 and 223, numbers chosen not for convenience, but for their unique mathematical properties to create the exact ratios needed to mirror these long astronomical periods. As researcher Tony and his team have articulated, the mechanism demonstrates a Hellenistic mastery of astronomy and mechanical engineering that far surpasses anything historians had previously imagined for that era. It proves that the abstract mathematics embedded in static stone monuments had a dynamic, mechanical counterpart. Here was a technology that could run the calculations in real time, turning the user from a passive observer into an active predictor of celestial events. The mechanism shatters our timeline of technological progress. It stands as a solitary, surviving whisper of a possibly vibrant tradition of geared science that was lost for centuries. It forces us to ask, if they could build this, what other mechanical wonders, now turned to dust, once existed. This portable computer of the cosmos reveals that ancient mathematical genius was not locked in stone alone, but could also be spun from bronze, a ticking clockwork model of the universe itself. El stands as a silent mathematician of stone, its 4 steep stairways counting the days in a year. This iconic stepped pyramid dedicated to the feathered serpent deity, is far more than a ceremonial platform. It is a sophisticated instrument, designed to speak to the eyes, the ears, and the intellect simultaneously. Its most celebrated performance occurs during the spring and autumn equinoxes. As the sun sets, the pyramid's northwest corner casts a series of triangular shadows down the balustrade. These shadows connect with stone serpent heads at the base, creating the breathtaking illusion of a diamond-backed serpent slithering down from the heavens to the earth. This is not a trick of light that happens by accident. It is the direct result of meticulous architectural calculation. The angle of each step, the precise orientation of the pyramid's corners, and its alignment to true north were all engineered to capture this specific solar alignment for only a few fleeting moments each year. It transforms a celestial event into a public spectacle, a divine confirmation of the cosmos's order made visible for all to witness. The pyramid's body is a calendar rendered in limestone. Each of its 4 sides has 91 steps. When you add the single, final step of the top platform, you arrive at a total of 365, 1 step for each day in the solar year. This numerical encoding is deliberate and elegant, a permanent, climbable almanac. But the mathematics of El engage another sense entirely, that of hearing. Stand at the base of the grand staircase and clap your hands once. The echo that returns is not a simple reverberation. It is a distinct, chirping sound that uncannily resembles the call of the sacred Quetzal bird. This acoustic phenomenon is a direct product of the pyramid's precise geometry. The spacing and height of the steps create a series of sound reflections that interfere with each other, filtering the clap's frequencies and producing that specific tonal chirp. The builders, whether by intention or through brilliant empirical discovery, engineered an environment where architecture itself could mimic the voice of a creature they held sacred. This fusion of visual astronomy and acoustic physics suggests a sensory philosophy of knowledge. The pyramid was not just to be seen, but to be interacted with, its lessons learned through light and sound. This integrated design extends to the entire city layout. El forms the heart of a vast astronomical observatory. A direct exists from the pyramid to the unique circular observatory known as El. From this tower, Mayan astronomers tracked the movements of Venus, a planet of critical importance in their cosmology. Other structures, like the Temple of the Warriors and the Great Ball Court, are positioned in precise geometric relationships to the main pyramid, creating a citywide grid that likely functioned as a giant calendar or cosmic diagram. Every game played in the ball court, with its impossible stone rings, and every procession along the sacred causeways, took place within this mathematically defined sacred space. Represents a pinnacle of interactive design, where encoded knowledge was not locked away but performed. The descending serpent, the chirping echo, the counted steps, all invited participation and awe. It demonstrates that for the Maya, understanding the universe was a holistic endeavor, engaging mathematics not as a dry abstraction, but as a living language that could make the stones whisper, count, and even sing. The allure of a lost golden age is a powerful story, one that whispers from the edges of our history. When faced with the staggering precision of the Great Pyramid or the celestial genius of the mechanism, a tempting question arises. Could this level of knowledge have sprung from ordinary human minds of that era, or does it point to something more extraordinary, like a forgotten advanced civilization or guidance from beyond our world? These theories form a fascinating, if controversial, chapter in our search for answers. Their core argument is compelling in its simplicity. They look at monuments like Puma in Bolivia, with its stone blocks cut with laser-like precision and interlocking like a three-dimensional puzzle, and ask how Bronze Age tools could achieve such a feat. They point to the astronomical alignments encoded across and wonder if the builders possessed knowledge of the precession of the equinoxes, a slow wobble in Earth's axis that takes 26,000 years to complete, a cycle seemingly too long for any single culture to observe. The conclusion some draw is that our conventional timeline is wrong. Perhaps a sophisticated society, like the legendary Atlantis, existed before a great cataclysm, leaving behind only fragments of their technology embedded in later myths and monuments. Or perhaps, as some propose, ancient astronauts visited Earth, gifting early humans with mathematical and architectural blueprints. These ideas are often presented as solving the mystery of the anachronism, the object or idea that appears out of its proper time. They fill the gaps in our understanding with grand, imaginative narratives. Mainstream archaeology and history, however, approach these same gaps from a different perspective. Scholars point not to a single lost source, but to the immense, cumulative power of human ingenuity across generations. They emphasize what we have lost, not to cataclysm, but to the slow erosion of time. The Library of Alexandria burned, countless scrolls decayed, and entire oral traditions faded away. The mechanism is a perfect example. It was a complete shock to modern historians precisely because it is a lone survivor. Its existence does not prove extraterrestrial help. It proves that an entire school of complex Greek mechanics existed, one that was simply lost for centuries. The response to seemingly impossible precision is often found in patient, hands-on experimentation. Researchers like the late stonemason Roger demonstrated that with simple stone tools, sand, water, and immense patience, one can shape and polish granite to a mirror finish. The trial and error of countless anonymous artisans, passing refined techniques down through apprenticeships, could achieve results that look miraculous to us today. This is the heart of the scientific principle known as razor. When presented with multiple explanations for a phenomenon, the simplest one that requires the fewest new assumptions is usually correct. Attributing the pyramids to human intelligence, organization, and generations of labor requires no new assumptions. We know humans are capable of these things because we see their results everywhere. Introducing a lost super-civilization or extraterrestrial contact adds vast, unproven layers of complexity without concrete evidence. This is not to dismiss the genuine, awe-inspiring mysteries that remain. We may never know exactly how the massive stones of Baalbek were and moved, or the full purpose of every alignment at. The gap in our knowledge is real. The critical skill for any explorer of history is to distinguish between a mystery, which is an unanswered question within the framework of evidence, and a myth, which is a story constructed outside of it. We can stand in wonder at the achievements of the past without needing to credit outside forces. In doing so, we do not diminish our ancestors, we empower them. We acknowledge the breathtaking scope of human creativity, persistence, and intellect. The true lost civilization is not Atlantis. It is the collective genius of those thousands of unnamed engineers, astronomers, and stonemasons whose lifetimes of work literally moved mountains. Their legacy is not a puzzle to be solved by invoking the supernatural, but a profound testament to the natural, extraordinary potential of the human mind when focused across centuries toward a single monumental goal. From the intricate clockwork of bronze gears, we are lifted high above a canvas of barren earth. The desert of southern Peru holds one of humanity's most enigmatic mathematical statements, drawn not in ink, but across 500 square miles of desert pavement. While the hummingbird and the spider capture the imagination, the true foundation of this art is geometric. Giant trapezoids stretch over hills like colossal landing strips. Sharp triangles point across the plains. Perfect spirals unwind beside lines so straight and so long they vanish over the horizon. These are not random scratches. They represent a staggering exercise in applied mathematics executed on a literally unimaginable scale. The first mathematical miracle is one of scaling. Researchers believe the artists likely began with small-scale models, perhaps sketched on textiles or plotted in miniature on the desert floor. The challenge was to transfer this design, perfectly proportioned, to a figure that could be several miles from end to end. They solved this with a system of simple yet brilliant surveying. By driving wooden stakes into the ground at key points and stretching ropes between them, they could establish straight lines and consistent angles. To maintain a line's straightness over a rolling hill, they would have used a series of aligned stakes, siding from one to the next to correct for the curvature of the land. This is practical geometry of the highest order, using line of sight and basic triangulation to turn a vast, uneven landscape into a precise drafting table. The precision they achieved is humbling. Modern analysis using GPS and photogrammetry has measured some of the straight lines. They do not waver. Over distances of many kilometers, their deviation is often less than a few meters, a degree of accuracy that rivals modern engineering projects. The geometric shapes, like the massive trapezoids, maintain their parallel sides and consistent angles despite crossing gullies and slopes. This was not art by feel, it was a meticulous, communal act of calculation, where a single misaligned stake could throw an entire design into chaos. The purpose behind this immense effort is where mystery takes flight. One enduring theory connects them to the sky. Certain lines do align with the rising or setting points of the sun, moon, and bright stars during solstices or other significant dates. They may have functioned as a giant celestial calendar, their pathways used for ritual processions that walked in step with the heavens. A more grounded, and perhaps more compelling, theory ties the lines directly to the most precious resource in this arid landscape: water. The culture thrived in one of the driest places on Earth, relying on underground aquifers. Many of the longest lines lead directly from the mountains towards sources of water. The trapezoids and triangles often point toward distant hills where seasonal water would flow. Researchers studying the region's hydrology note that they may have been part of a vast ritual system of water worship and petition. Walking these lines could have been a ceremonial act to summon life-giving moisture from the earth and sky, a desperate and beautiful mathematics of survival. This leads to the most profound puzzle of all, the question of perspective. The creators of the lines could never have seen their work as we see it today. They walked beside it, across it, within it. The full, majestic form of a 200-meter-wide monkey or a kilometer-long trapezoid is only visible from the air, a vantage point utterly impossible for the people who made them. So who were these designs for? This is where mathematics transcends tool and becomes offering. The precision, the scale, the unwavering straightness, all suggest these forms were meant to be perceived by entities that could see from above. They were messages or offerings to the gods of the sky and the mountain, a geometry of devotion written in the earth itself. It was a mathematics of faith, where perfection was not for human praise, but for divine acknowledgement. The lines challenge our very definition of art and purpose. They are giant geometric proofs, solved not on parchment, but on the planet, a permanent testament to a culture that measured its prayers in miles and offered its devotion in perfect, invisible lines. The same numbers and shapes emerging across continents presents history's most captivating puzzle. How is it that the pyramid form, a geometric mountain pointing to the sky, arose not only on the sands of Egypt, but also in the jungles of and the plains of Southeast Asia? How did the golden ratio and the concept of pi find their way into stone structures built by cultures that, according to our textbooks, never met? This leads us to a grand debate that has captivated explorers and scholars for centuries, the question of transmission. Did this knowledge travel, or was it born anew in each place? One school of thought, known as argues for ancient contact. Proponents look at the striking similarities and ask, could it all be coincidence? They suggest mechanisms like ancient sea voyages far more ambitious than we've credited. Perhaps Phoenician traders, renowned sailors of the ancient Mediterranean, carried architectural ideas across the oceans. Or maybe a shared, even older ancestral culture, whose memory survives only in myth, seeded these concepts around the globe. The stories of great floods and lost civilizations found in countless traditions could be echoes of this profound, forgotten connection. The diffusionist view paints a picture of an ancient world humming with exchange, where a master builder's idea could, ripple outward to shape a temple on the other side of the planet. The opposing view, championed by many anthropologists and historians, is one of independent invention. This argument rests on a powerful premise, the convergent evolution of the human mind. It suggests that when disparate cultures face the same fundamental human challenges, they often arrive at startlingly similar solutions. Think of the problem itself. A society wishes to build a monument that reaches toward the heavens, demonstrates the ruler's divine power, and stands for eternity. What is the most stable, impressive form for such a structure? The pyramid, with its wide base and sloping sides, is a brilliant answer to that universal question, an elegant solution to the physics of stacking stone. It emerges not from shared blueprints, but from shared logic. The same principle applies to mathematics. Any culture that studies the stars will eventually discern cycles. Any culture that measures circles will stumble upon a constant close to pi. Any artist seeking a visually pleasing proportion may, through trial and error, converge on the golden ratio. In this light, the monuments are not proof of contact, but proof of a universal human ingenuity. Isolated minds, gazing at the same stars and grappling with the same stones, can independently discover the same eternal truths. This debate forces us to examine the evidence with a critical eye. The pyramids of Egypt, and while similar in silhouette, are profoundly different in purpose, construction, and internal meaning. The Egyptian pyramids were primarily tombs, sealed monuments for a single journey to the afterlife. The pyramids were functioning temples, with steep stairways for priests to ascend and perform public ceremonies, often with temples at their summits. Their internal chambers, construction methods, and religious functions share little beyond the basic shape. This suggests that the form served different cultural needs, arrived at independently. Similarly, the appearance of complex astronomical alignments everywhere may simply reflect the fact that the sun, moon, and stars are the only universal clock available to ancient societies. Observing solstices is not advanced knowledge. It is a basic, survival-level observation for any agricultural community. Yet, the possibility of some transmission cannot be entirely dismissed. The archaeological record is fragmentary, and the oceans were highways, not barriers, for many ancient peoples. The sweet potato, a plant native to the Americas, was found in Polynesia long before European contact, suggesting prehistoric voyages across the Pacific. If a root crop could travel, why not an idea? Perhaps it was not a direct transfer of complex geometry, but a slower, more subtle diffusion of core concepts, like the symbolic power of certain numbers or the desire to align buildings with celestial events. These seed ideas could then take root in different soils, growing into the distinct but familiar forms we see today. Ultimately, this mystery may not have a single, neat answer. The truth likely lies in a blend of both forces. Some concepts may have traveled along ancient trade routes, carried by storytellers, artisans, or explorers. Others were undoubtedly born from local genius, the product of centuries of observation and innovation. This debate, however, is about more than just history. It is about how we understand human potential. Does it diminish our ancestors to think they invented these wonders alone, or does it make their collective achievement even more magnificent? The interconnected mystery of these stones is, at its heart, the mystery of the human mind itself, a mind capable of the same profound insights, whether on a Nile riverbank or a plateau. This shared mathematical impulse points not necessarily to a shared teacher, but to a shared nature, an innate drive to measure, to pattern, and to seek harmony with the cosmos. And if that drive is woven into us all, what does it mean for the legacy we are building right now? In our own age of stone and steel, while ancient eyes saw patterns in the stars, modern science now gives us vision that pierces soil, stone, and jungle canopy. The detective work has entered a new era, where speculation is being replaced by hard data, revealing mathematical blueprints we could never see before. One of the most revolutionary tools is LiDAR, which stands for light detection and ranging. Imagine flying a plane over a dense rainforest, like those covering parts of Central America. The laser pulses from a LiDAR system pass through the smallest gaps in the leaves, bounce off the ground, and return to the sensor. When researchers strip away the digital vegetation from the resulting data, the landscape beneath is laid bare. What appears as an unbroken green blanket to the naked eye is suddenly revealed as a vast, engineered grid. In places like the Maya lowlands, LiDAR has uncovered entire cities, with thousands of previously unknown structures, causeways running in perfect straight lines for miles, and agricultural terraces arranged with geometric precision. This technology shows us that what we thought were isolated ceremonial centers were, in fact, sprawling metropolitan complexes, their layouts governed by a mathematical order on a scale we never imagined. Another powerful tool is photogrammetry. This process involves taking hundreds of overlapping photographs of an object or site from every possible angle. Specialized software then stitches these images together to create an exquisitely precise three-dimensional model. For archaeologists, this is transformative. They can now measure the exact dimensions of a carved stone statue from halfway around the world, or analyze the wear patterns on a temple step to understand centuries of foot traffic. This digital preservation allows for a level of analysis that is both invasive and incredibly detailed, turning a monument into a dataset where every angle and proportion can be tested against mathematical theories. Meanwhile, ground-penetrating radar sends pulses into the earth, painting a picture of what lies below without a single shovel touching the ground. It has mapped buried walls, detected the outlines of ancient plazas, and even hinted at the presence of unseen chambers, all hidden beneath our feet. Satellite imagery, too, has moved far beyond simple photography. Multispectral sensors can detect subtle differences in soil moisture or plant health, revealing the ghostly outlines of long-buried ditches, foundations, and geometric earthworks that are completely invisible from the ground. These tools are not just creating maps, they are solving specific, long-standing puzzles. At Stonehenge, high-resolution laser scanning of the standing stones revealed something the naked eye could never catch: dozens of ancient carvings of axe heads and daggers on the stone surfaces. More importantly, this scanning provided such precise measurements of the stone's shapes and positions that it allowed researchers to digitally test astronomical alignment theories with unprecedented accuracy, refining our understanding of how the monument functioned as a celestial observatory. In Egypt, a technique called muon tomography is peering deep into the heart of the Great Pyramid. Muons are subatomic particles that constantly rain down from the atmosphere, passing through solid matter. By placing sensitive detectors inside known chambers and measuring how many muons pass through from different angles, scientists can create a density map, much like a medical CT scan. This process recently detected a significant void above the Grand Gallery, a hidden space that had eluded discovery for 45 centuries. This is not treasure hunting, it is structural analysis, helping us understand the internal architecture and construction methods of the pyramid on a fundamental level. Every scan, every radar pulse, every digital model adds another piece to the grand puzzle. What these technologies collectively demonstrate is that the ancient mathematical mind was even more sophisticated and systematic than we realized. The perfect straight lines revealed by LiDAR in the jungle show a command over large-scale surveying. The hidden chambers suggested by muon scans imply a complexity in architectural planning that we are only beginning to grasp. This ongoing technological revolution does something vital. It grounds our wonder in evidence. We are no longer just interpreting what we see on the surface. We are decoding the full, three-dimensional intention of the builders. The story is not finished. The stones are still speaking, and now, for the first time, we have the tools to listen to every whispered word. Our search for numbers in stone reveals as much about us as it does about the ancients. This deep-seated fascination is not a modern quirk, but a fundamental feature of the human mind. We are, by our very nature, pattern-seeking creatures. For our distant ancestors, spotting the subtle pattern of a predator's tracks in the mud or the predictable ripening of berries in a certain season was not an intellectual exercise. It was a matter of life and death. This hardwired instinct to connect dots and predict outcomes is the same cognitive engine that thrills when we see pi in a pyramid or a calendar in a staircase. We are applying an ancient survival skill to a modern historical mystery, and the feeling of solving it, of cracking a code left to go, delivers a profound sense of satisfaction. It feels like a direct line of understanding across time. This desire for order runs even deeper. We live in a complex, often chaotic world. To discover that our ancestors, whom we might unconsciously label as primitive, possessed such sophisticated knowledge offers a comforting narrative. It suggests an underlying order to human history, a thread of genius that connects us all. It transforms these ruins from piles of rock into purposeful messages, making the vast and indifferent sweep of time feel more intentional, more meaningful. The philosopher Carl spoke of a collective unconscious, a shared reservoir of symbols and archetypes that transcends culture. Could our universal awe at these geometric monuments tap into something like that? A shared human reverence for the circle, the spiral, the perfect angle? Psychologists note that engaging with an unsolved puzzle activates our brain's reward centers. The mystery of the stones is the ultimate puzzle, one with no definitive answer sheet, allowing for endless exploration and theory. This sense of wonder is the true treasure. When we stand before the Parthenon or study the lines of, we are not just analyzing engineering. We are experiencing a moment of connection with minds that saw the same stars, that grappled with the same existential questions, and chose to answer them with breathtaking precision. We perceive them as enlightened, which in turn makes us feel connected to something grander than our own moment in history. Yet this powerful drive has a shadow, a cognitive bias we have touched on before called apophenia. This is the tendency to perceive meaningful connections between unrelated things. Our pattern-seeking brains are so eager for order that they can sometimes impose it where none exists. This is why the same set of ruins can inspire both rigorous archaeology and elaborate speculation. The line between a profound discovery and an imagined pattern can be incredibly thin. It is the difference between measuring a statistically significant alignment to the winter solstice sunrise and finding the golden ratio in a structure by selectively choosing which points to measure. Our fascination, therefore, requires a gentle balance between wonder and critical thinking. We must allow ourselves to be amazed by the clear intent of a solstice alignment while also questioning the more tenuous claims of hidden numerical codes. This self-awareness does not spoil the mystery, it deepens it. It means that when we do find verifiable, repeated mathematical principles across cultures, their significance is only they have passed through the filter of our skepticism. So this journey through ancient mathematics is, in the end, a mirror. We gaze across centuries looking for order, and in doing so, we discover the contours of our own minds, our innate need for meaning, our capacity for awe, and our perpetual struggle to distinguish signal from noise in the beautiful, confusing legacy of the past. A mandala is a map of the cosmos, a circle within a square representing the universe in microcosm. In central Java, an entire mountain was carved into one. Borobudur, the world's largest Buddhist temple, is not a building with interior rooms. It is a three-dimensional mountain of enlightenment, a staggering 9-tiered structure of dark volcanic stone that pilgrims ascend in a silent, clockwise spiral. From above, its plan reveals a profound geometric intention, a perfect mandala made real. A massive square base supports 5 concentric square terraces. These are then crowned by 3 circular platforms, culminating in a majestic central stupa, a bell-shaped monument pointing to the sky. This progression from the square, symbolizing the earthly and material world, to the circle, representing the celestial and formless realm, is the entire spiritual journey made into architecture. You do not simply look at Borobudur, you walk its sacred geometry, moving from illusion toward awakening with every step. The mathematics of this path are precise and deeply symbolic. The entire monument is a symphony of sacred numbers. There are precisely 504 statues of the Buddha seated in meditation niches along the square terraces. The walls are adorned with 2,672 intricately carved relief panels, which, if read in order, form a continuous visual narrative of Buddhist teachings, spanning a length of over 3 miles. At the top, on the 3 circular platforms, sit 72 latticed, perforated stupas, each housing a statue of the Buddha inside. These numbers are not random. In Buddhist cosmology, they resonate with meaning. The number 72, for instance, is often associated with auspicious completion and spiritual fulfillment. The entire structure becomes a numerical text, its counts and repetitions a form of meditation in stone, reinforcing doctrinal principles through sheer, overwhelming repetition. This mathematical order extends beyond the temple itself into the landscape. Borobudur is positioned in a sacred valley, framed by 2 pairs of volcanoes. Researchers have noted that during the equinox, when day and night are of equal length, the sun rises directly over one of these distant peaks when viewed from the temple's eastern side. This alignment suggests the site was not only a spiritual map, but also a cosmic clock, its position carefully calculated to harmonize with the solar cycle. The experience of the pilgrim is thus framed by both earthly geometry and celestial time, a total immersion in a mathematically ordered universe. The ultimate purpose of all this precision is transformative. The pilgrim's walk to the summit is a physical enactment of the path to nirvana. The square terraces, called the realm of desire, are decorated with reliefs depicting the causes of suffering and the lessons of moral law. As you ascend to the circular platforms, the realm of form, the open lattice stupas offer fragmented glimpses of the Buddha within, symbolizing the gradual piercing of illusion. Finally, at the central, solid stupa in the realm of formlessness, all imagery falls away. The empty, unadorned dome represents the ultimate goal, a state beyond form, beyond number, beyond description. Borobudur is therefore the ultimate fusion of mathematics and metaphysics. It uses geometry and numerology not for engineering or astronomy, but as a scaffold for the human spirit. It is a walkable equation where every step, every statue, and every number is a variable in the calculation of liberation, proving that the most profound mathematics might not be about measuring the world, but about transcending it. These stone equations were never meant to be static. They were seeds, planted in the ancient world, whose roots now support the entire structure of our modern reality. The geometry used to align a pyramid or proportion a temple did not vanish. It evolved, traveling through time on a journey from sacred practice to scientific principle. This lineage is direct and profound. The practical land surveying of the Egyptians, Their mastery of area and volume calculation for building and agriculture provided a crucial foundation. Greek scholars like Thales and Pythagoras, who reportedly studied in Egypt, absorbed this empirical knowledge and transformed it. They asked not just how to measure a field, but why the rules of measurement worked, seeking the abstract proofs behind the practical results. This shift from applied technique to theoretical philosophy was monumental. It created the discipline of geometry as we know it, a system of logic and deduction that would become the bedrock of Western thought. Centuries later, during the Renaissance, artists and architects rediscovered these Greek texts, often preserved by Islamic scholars. They saw in ancient geometry the key to recreating the lost perfection of classical art and architecture. The meticulous studies of proportion by Leonardo da Vinci, in his Man, and the harmonious designs of domes were direct revivals of this ancient mathematical pursuit. This rediscovery fueled not just an artistic revolution, but provided the intellectual framework for the scientific revolution that followed. When Galileo sought to describe the motion of planets, they turned to geometry, the very language the ancients believed ordered the cosmos. The circle, so sacred to monument builders, became the orbit in early models, a beautiful testament to the endurance of an idea. Our daily lives are filled with silent echoes of this ancient math. Look at the circle of a clock face, divided into 360 degrees. This number comes not from nature, but from the Babylonian astronomers who, over 3,000 years ago, used a base 60 number system for their celestial calculations. They divided the circle into 6 times 60, a convention so practical it has spun through into every classroom and navigation system on Earth. The concept of zero, essential for everything from calculus to computer code, has its philosophical roots in the profound emptiness sought in meditative practices like those at Borobudur, before Indian mathematicians formalized it as a number. Our units of angle and time, minutes and seconds, are Babylonian 60-based increments. Even the 7-day week is a legacy of the 7 classical planets observed by stonemasons and stargazers alike. These are not mere curiosities, they are the living infrastructure of our global civilization, built on ancient foundations. The pursuit of visual harmony, so meticulously encoded in the Parthenons, never ceased. It simply migrated from temples to town squares, from cathedrals to concert halls. The same golden ratio and principles of geometric balance studied by the Greeks consciously guided the work of Renaissance masters and Enlightenment architects. Today, this legacy continues, often unconsciously, in the sleek lines of modern design. Industrial designers use these timeless proportions to create products that feel intuitively right in the hand. Graphic artists employ sacred geometric grids to build layouts that are pleasing to the eye. The ancient desire to build structures that resonate with a deep, human sense of order now shapes our skylines and our smartphones. When we find a building beautiful or an object elegantly simple, we are often responding to the same mathematical relationships that a priest-architect sought when aligning a temple to the rising sun. Therefore, to walk among these ancient monuments is not to visit a museum of dead ideas. It is to tour the active construction site of the human intellect. Every solstice alignment observed at Stonehenge was a step toward our understanding of orbital mechanics. Every precise right angle laid at Giza was a brick in the foundation of engineering. Every fractal pattern repeated at Angkor Wat was an early exploration of recursive logic. By studying these stones, we are reading the foundational chapters of our own story, a narrative written not in ink, but in aligned limestone and calculated granite. They remind us that our science, our art, and our very way of quantifying reality are not sudden inventions, but a living legacy, a conversation with the past that continues to shape every equation we write and every structure we raise toward the sky. Buried on a windswept hill in southeastern Turkey, a discovery is shattering our timeline of human ingenuity. Is not merely old, it is staggeringly ancient, built over 11,000 years ago. That is 6,000 years older than Stonehenge, 7,000 years before the Great Pyramid. This was a time before pottery, before metal tools, before the wheel, and long before the first cities or written words. Yet here, hunter-gatherers carved and raised the world's first known monumental architecture. The site is a series of circular enclosures, each defined by a ring of massive, limestone T-shaped pillars, some weighing over 10 tons. These are not rough stones. They are elegantly shaped, smoothed, and often adorned with exquisite relief carvings of animals, foxes, scorpions, birds, and snakes, creatures that roamed a very different world. The sheer scale of labor is breathtaking, but the true revolution lies in the silent language of its layout. When archaeologists mapped the positions of these pillars and enclosures, a pattern emerged. The centers of the three oldest, largest circles form a nearly perfect equilateral triangle. The distances between key features appear to follow deliberate geometric relationships. This is not a haphazard arrangement of impressive stones, it is evidence of a plan, a shared mental blueprint executed across generations. These builders, who had not yet domesticated a single plant or animal, were thinking in abstract shapes, calculating distances and angles to create a precise, sacred geometry. The implications are profound. It means the human capacity for complex mathematical thought and large-scale project coordination did not emerge as a product of agriculture and surplus, as historians long believed. Instead, this capacity may have been the very catalyst that brought people together, a shared intellectual and spiritual drive that preceded and perhaps even inspired the settled societies that followed. The carvings offer another tantalizing clue. Among the menagerie of beasts, some researchers see more than mythology. They propose that certain groupings, like a scorpion, a bird, and a circle, could represent constellations as they appeared in the night sky 11 ago. If true, this would push back the origins of systematic astronomy by thousands of years, suggesting these early builders were not just shaping the earth, but mapping the heavens, using stone to capture their observations of the celestial order. Stands as a quiet, monumental rebuke to the linear story of human progress. Forces a humbling reconsideration. Perhaps mathematics and monumental art are not the luxuries of civilization, but fundamental expressions of the human mind. Long before we wrote laws or built granaries, we gathered under vast skies, measured circles in the dust, and raised pillars to the unknown, driven by a deep, innate need to find pattern, meaning, and awe in a world we were only beginning to understand. The story does not end with the final stone placed at, it continues with you. These ancient puzzles are not locked away in a museum, they are waiting in the open air, and you can become part of the ongoing conversation. This journey from passive viewer to active explorer begins with a shift in perspective, seeing the landscape not just as scenery, but as a living textbook of geometry and alignment. Your own curiosity is the most important tool you bring. If you are fortunate enough to visit one of these sites, prepare to engage with it mathematically. Before you go, spend time with a site map. Notice the basic shapes, the cardinal orientations, and the relationship between structures. When you arrive, resist the urge to simply snap a photo and move on. Find a quiet moment to stand at a central point. Use a simple compass app on your phone to check the alignment of a wall or pathway. During a solstice or equinox, observe where the sun rises or sets in relation to the architecture. These simple acts of observation connect you directly to the ancient builder's process, transforming a tourist visit into a personal experiment. Always remember to visit responsibly, following all local guidelines to preserve these fragile sites for future generations. Your exploration is not limited by geography. Digital tools have democratized discovery. With free applications like Google Earth, you can fly over the lines, examining their staggering geometric precision from above. You can measure the perimeter of the Great Pyramid of Giza or trace the perfect circles of Stonehenge. Many universities and cultural institutions now offer high-resolution three-dimensional scans of artifacts and monuments online, allowing you to inspect carvings and angles from your own home. To deepen your understanding, seek out reputable sources. Books by archaeologists like, or offer accessible, evidence-based insights into ancient astronomy and engineering. Documentaries produced by major scientific institutions or public broadcasters provide a trustworthy visual foundation, while being wary of sensationalized claims that promise easy, revolutionary secrets. You can even contribute to real research. Numerous citizen science projects welcome the help of enthusiastic amateurs. Platforms like Host Projects, where you can help archaeologists classify pottery shards from satellite imagery or transcribe ancient weather records. These efforts aggregate the power of many curious minds to solve problems that would overwhelm a single research team. By participating, you become part of the very process of uncovering history, adding your own observation to the collective pool of knowledge. As you embark on this path, a crucial companion must be a keen awareness of your own mind's tendencies. We are, as we have discussed, innate pattern seekers. This beautiful trait has a shadow called confirmation bias, the subconscious urge to seek out and interpret information in a way that confirms what we already believe or hope to find. It is the reason two people can look at the same set of ruins and see completely different patterns, one seeing a random assortment of stones and the other seeing a precise star map. To navigate this, cultivate a mindset that balances wonder with rigorous questioning. When you encounter a claim about a hidden mathematical code, ask for the evidence. Are the measuring points clearly defined architectural features? Does the same pattern appear consistently, or is it cherry-picked from one angle? Would the builders have recognized and valued this specific calculation? This skeptical curiosity does not dampen the magic, it refines it, ensuring that the truths you uncover are as solid as the stones themselves. Ultimately, engaging with these mysteries is an invitation to a lifelong practice. It is a call to blend the poet's sense of awe with the scientist's demand for evidence. Respect the profound spiritual and cultural meanings these monuments held for their creators, while honoring the meticulous work of modern researchers who piece together their story fragment by fragment. Let the unanswered questions fuel your curiosity, not your frustration. The greatest legacy of these ancient mathematicians is not a solved equation, but an awakened perspective, a way of seeing the world that finds profound order in both the grand sweep of a pyramid and the precise angle of a shadow at dawn. The stones have been speaking for. Now, it is your turn to listen, to measure, to question, and to add your own voice to the eternal conversation between humanity and the cosmos. The stones have spoken, and their message is one of universal genius. From the sun-baked pyramids of Egypt to the cloud-wrapped temples of the Andes, we have traced a single, shimmering thread of human thought. These monuments are not relics of a superstitious or primitive past, but permanent libraries, their shelves stacked with volumes written in geometry, astronomy, and number. Our ancestors were master geometers of their world, using the most durable material they could find, stone, to encode their deepest understanding of the cosmos. They measured the heavens to track time, mapped the sacred to connect with the divine, and calculated proportions to create harmony that still resonates today. Whether a structure was a deliberate calculator like the mechanism, a symbolic blueprint like the mandala of Borobudur, or a magnificent fusion of both like the celestial clock of, the underlying impulse was the same, a profound drive to find order in the universe and to leave a lasting imprint of that understanding. This shared language of number and form connects us across oceans, and it tells a story far richer than the chronicles of kings and conquests we often focus on. It is the story of the human mind itself, of our innate curiosity and our relentless pursuit of meaning. This journey invites us to reframe history, to see it not just as a sequence of events, but as a gallery of ideas etched in architecture, a silent conversation between generations of thinkers, builders, and dreamers. So the next time you look at an ancient wonder, whether in a photograph or in person, try to see beyond the weathered surface. Look for the circle within the square, the alignment to a solstice sunrise, the repetition of a sacred number. See the architect not as a distant myth, but as a fellow problem solver, a philosopher in stone. Let this exploration remind you that the capacity for wonder and calculation resides within us all, a legacy passed down not in genes, but in the very angles of our shared heritage. I would love to hear which mathematical mystery captured your imagination the most. Was it the precise pi of the Great Pyramid, the celestial calendar of Stonehenge, or the fractal universe of Angkor Wat? Share your thoughts in the comments below. If you enjoyed decoding these secrets with me, please subscribe. Together, we will continue to explore the hidden equations of history, listening for the next whisper